Hey, what's happening, guys? I'm glad you guys enjoyed the videos on the make your own function generators. Yeah, like I said, it's pretty simple stuff, but it's a lot of fun. And it's one of the reasons I love electronics, just to take simple things like the 555 timer and a resistors and a capacitor, and you can reshape waves and change them around. And that's I want to talk a little bit more about that today, because there are some questions I had as to why does it work and how does it work. So we're ignoring the whole 555 thing. I've gone over it many times. I'm sure you guys are tired of hearing about it. So we know that we just get a simple square wave out of the 555. We'll say, 555 magic goes on back there. So then what we did is we simply created a basic low-pass filter, right? We have a resistor. And then a capacitor to ground. And this is where our square wave was input. And then over here is our output, which after some tuning becomes a nice triangle wave. But before tuning, you get more of a sawtooth wave. So why is that happening? Well, this is the RC low pass filter, but it's also an integrator. And what happens is as our square wave comes in to the integrator, the pulses are sped up. So if we say that, we'll take this as our zero line, and we'll say this is our square wave. Okay, so that's 0 volts. Let me grab a different color pen here. And then we'll see what ends up happening here. Is our pulses are sped up, and they do not reach the full amplitude of the square wave. So instead of the very nice sharp very sharp on, I think my blue pen's about had it, and then off, what we're getting is more, oh boy, more of this capacitor charging curve for on, and then the rapid drop off. Okay, the blue pen is now officially dead. And we're back to the black pen. So you can see here again, like I said, our integrated signal, our triangle or sawtooth wave, is not reaching the amplitude here. You've got this little missing space here. And the reason that makes such a great low-pass filter is because we can design an amplifier or whatever we need that only passes signals of a certain layer or level, or amplitude. So that's why that makes a great low pass. Now, if we come on again and we take our 555 square wave, or it doesn't have to be a 555, anything that's going to generate a square wave, and we do the opposite circuit, something like this, so our input square wave is fed in here, and we take our output over here, what we get now is basically the opposite of that. And what we see are these very sharply defined peaks. Very sharp peaks. It's a symmetrical wave. I mean, they're both symmetrical, but this is definitely a symmetrical wave. But in this case, you're going to get both positive peaks and negative peaks. And this is our differentiator circuit. So it's nice for creating very narrow pulses, because again, we can easily ignore this stuff here in the middle and simply focus on our peaks. Just another way of reshaping the waveform. And these have all been RC circuits, which are, of course, resistor capacitor circuits. Now, we can change this up a little bit, take out the resistor, and put in an inductor. And now we have an LC circuit, and that will also reshape waves. So again, if we take our signal, and we can have either a sine wave or a square wave, we'll talk about both. Let's start out with a square wave. Nice, we'll call it a relatively slow square wave, say like, you know, a kilohertz. And we put it through an inductor. And we take our output over here. Well, what we're going to get out is this kind of pattern. That same sawtooth pattern. And why do we get that? Come on, you guys should know, right? What does an inductor resist? It resists a change in current. So as it's resisting that change, we're getting that buildup. Then it drops. Then it's resisting and it drops. Resisting and it drops. Now, if we speed it up and put in a faster square wave, say this is 1 megahertz. Well, now, when we put it through that same inductor, everything changes. Because that inductor has a frequency range, and all we end up getting is kind of an ugly, attenuated sine wave. Because this frequency is out of the range of the frequency of that inductor. Now that's what happens to square waves. What happens when we do the same thing to sine waves? So if we put in a nice sine wave into our inductor of a certain specified inductance, what we end up getting out is kind of basically the same thing. But if we input a signal of a much higher frequency, what we end up getting is that same flattened, attenuated sine wave mess that we saw earlier. So the coil won't do as much to the sine wave as long as these two, the coil and the frequency of the sine wave, are matched. If it's outside of the region that the inductor is active, well, in that case, then it's just going to step all over your sine wave. The one last thing we have to be careful with an inductor. Let's say, you know, we throw in our square wave. Could be a sine wave, doesn't really matter. And we pass it through the inductor. What is going to come out on this end is not so much going to be that beautiful sawtooth pattern we saw, but it's going to be more of a wave that looks kind of like this. And these little areas here are what are called ringing. Oops. You're going to get ringing is when whatever is outside of this little part of our circuit, you know, say for instance, we've got a resistor on there for a load, and that resistance is high, that's going to cause the ringing. So if we're talking about square wave or sine waves, then we're going to have to talk about the impedance of the circuit. But if we just stick with a square wave, we can talk about the resistance of the circuit. And you want to keep that external resistance low so that you don't end up with ringing on your circuit. If you take a look at a square wave with ringing, you're going to see a big peak, and then it's going to die away. Big peak, die away. And that's your classic ringing. And that happens, like I said, when the external resistance to this coil is high. So I think I've rambled on enough about circuits and wave shaping and RC and all that stuff. Hope you guys enjoyed this. If you did, feel free to comment, share, and don't forget to subscribe. Big thanks to you guys for watching. Big thanks to all the patrons. That's it. I'm out. Peace.